Let us do some problems on conditional probability. Assume that each born child is equally likely to be a boy or a girl. If a family has two children, what is the conditional probability that both are girls given that the youngest is a girl? Now, what will be the sample space for this experiment, this survey? If we go to the families of two children only, the possible outcomes are these four. Both are girls, elder one girl, then boy, first one boy and then girl, or both boys. So all possible outcomes, the set forms the sample space. And it is very clearly said. You need to assume that each born child is equally likely to be a boy or a girl. So these four outcomes are now treated to be equally likely to happen. So let me call the first condition, the probability that I want to find, the condition event A. Both are girls. This condition's probability is what I want to find out. So let me call it event A. So probability of A will be the ratio of the number of outcomes favorable to this condition A upon the total outcomes 4. Which are the possible outcomes favorable to the event A? This is the only one. Both are girls. Both are girls here. So 1 upon 4 is the probability. Now, it's not the simple probability that we are asked to find out. We are asked to find the conditional probability on the given information that another condition. Let me call it B. It's another event B. Youngest is a girl. So let me see what is the simple probability of this new condition. Youngest is a girl. These are the two. These tick mark ones. Youngest is girl. Youngest is girl. So simple probability of B would have been 2 out of the total 4, 2 by 4. But again, what are we asked to do? We are asked to do, look at the statement once more. The conditional probability of A given B. Probability of A given B. That is what we want to find out. Which can be found out by the formula only. Probability of the intersection of A and B upon probability of B. What is the intersection? Intersection means common elements to the conditions A and B. So the common elements we are looking for. Both time we highlighted this one. This was under this condition both are girls as well as under this condition youngest is a girl. So this GG happens to be the common element. This one. Therefore, the probability of the common element, the intersection would be 1 out of the 4, 1 by 4. Denominator probability of B is 2 by 4 itself. So the required conditional probability is, on simplification we reach 1 by 2. Now, there is one more case. We need to treat it as a fresh case. The conditional probability of A, given that the given condition if it is at least one is a girl. Let's discuss it. This time, again, A is taken as the first event. Probability is equal to 1 by 4 already calculated. Now, the second condition, the given information is this. Second part. At least one is girl. Let me call it event C. So what is the probability of C? Simple probability of C. At least one is girl. Which are the outcomes satisfying? At least one is girl. Yes. These are the three of them. At least one is girl in these three cases. So the probability of C would be 3 by 4. Now, this time again let's observe the question. Conditional probability of A given C. Probability of A given C is what we are looking for. A given C. Appropriate formula will be probability of A intersection C upon probability of C intersection, the common elements. Which are the outcomes we highlighted both time? Again, this is the only one highlighted both time for A also, for C also. So, the common element probability will be again 1 by 4. So, according to the formula, the intersection probability that is 1 by 4 upon probability of C that is 3 by 4, the result is 1 by 3.